This webcast continues in Worksheet 8F, looking at problems 5 and 6. So in problem number 5, we're talking about a situation where someone maybe in New York City, let's say they live in an apartment that's up high and they need to lift their piano to a second floor window in order to move it into their place. And so it says how much work is done to lift this piano 12 meters to the second floor window. So I'm thinking that our system should be the piano and the earth. And at the beginning, I imagine the piano is at rest, not moving, and it's on the ground. And when we look at it again, the piano is at rest. It's not moving, but it's 12 meters above the ground. Okay, so let's think about what kind of energy this system has at both position A and position B. So at position A, the piano is on the ground. So the height is 0. There is no gravitational potential energy. It's not moving, so there's no kinetic energy. And a piano doesn't bend and bounce back, so it's not storing any elastic energy. It has no mechanical energy at the beginning. But at position B, what's changed is that now it's 12 meters above the ground. So it has a lot of gravitational potential energy that it didn't have before. Where did that energy come from? It came because the movers, or whoever is, moving this piano, they lifted it up. They had to apply a force that made the piano move upward. And so they did work on the piano because someone outside the piano earth system applied a force that caused the piano to move. That force did work and transferred energy into the piano's system. And so our conservation equation becomes the work that was done on the piano equals the change in the gravitational potential energy. Okay, and the problem is asking us to calculate how much work was there. So I'm just going to write that conservation equation over here again. Now, they did not give me the force that was applied or the, how far the force was applied to the piano. So I can't calculate work by the F delta X formula, but the work equals the change in the gravitational energy, and I definitely can calculate that. I know that the EG was 0 at position A, and at position B, it is the mass of the piano, which is 150 kilograms, times G, which is 9.8, times the height of the piano at position B, which is 12 meters. So I could calculate the work by looking at how the energy of the system changed. And I get that the work was 17,640 joules. Okay, let's take a look at number 6. So here we're saying how much work is done when a 50 kilogram box falls off the back of a truck. So at position, and we're probably talking about the box and the earth being our system, and at position A, the box is at rest 1 meter high, right? It's sitting on the, whatever, the bed of the truck. So it's 1 meter above the ground. At the end, the box is at rest, but it's on the ground. Look at this. Here, we have a situation where initially the box has gravitational potential energy because it's 1 meter above the ground. At the end, it doesn't have any gravitational energy or any other kind of mechanical energy, right? It's on the ground. So Eg is 0. It's not moving, so there's no Ek, and so on. Somehow, energy has left our system. Oh, and you know what? I'm going to erase the Earth from our system. Somehow energy has left the system of the box. And so we have that the change in the gravitational potential energy equals the work. And what's happening here is that the box is falling down, and so by the force of gravity exerted on the box, the energy in the box's system is actually being reduced. So here's a situation where work is being used to take energy out of our system instead of bringing energy into our system. And it says how much work was done. So I want to look at this. The change in the gravitational energy equals the amount of work that was done. Let's see, our mass. So that would be mg times the h at position A equals the work that was done. And then as I plug in, I'm going to make sure everything is in standard units. 50 kilograms times 9.8 times 1 equals the work. And so we get that the work was 490 joules. And in this case, that much energy was removed from the system of the box.